Okay, finally something that's not an elevator, right? We got a good juicy rocket, right? It can generate 513 newtons of thrust. In what time can it reach a speed of 63.9 meters per second? Neglect the change in mass of the rocket. So I think this is going to be one where we do a SUVOT problem at the end, right? So we're going to get an acceleration and then do the SUVOT at the end. So here, let's do our rocket ship. Here's our rocket. Got to draw a good rocket. Okay. And this rocket, this is a 23.1 kilogram. And of course, the 513 newtons of thrust is not the only force acting on it, right? But it's one of the forces. Okay, that's going to be a positive force. The downward force will be the weight, right? The weight is m times g, right? So 23.1 kilograms times 9.81 newtons per kilogram. 23.1 times 9.81. This is 226.611. That's the weight of the rocket, right? And that's going to be a downward force acting on this thing. Okay, so minus 226.611 newtons. And that, I guess we need to draw this arrow a bit longer, right? Because the upward force is a bit bigger than the downward force, right? And now we can set up our F equals ma. Right, so the forces are 513 newtons of thrust, that's upward. Okay, minus 226.611. And then that equals 23.1 times A. And A is what we're trying to find, right? So I'm going to subtract these two, and I get a positive force, a net force of 286.389, right? And that's 23.1 times A, right? And now I can divide both sides by 23.1, and I get that the acceleration is positive, assuming this thing's moving upward, right? Okay, positive 12.398. How many sig figs do we have? Oh, okay, well, anyway, we got 5 there, right? Here we've got 3, so definitely if we have 5 sig figs and carry that forward, we're set. Now we're going to just carry that across, and now we just have to do a SUVOT problem, right? Okay, let's see. Let's change colors here. How about red? Red's a juicy color, right? So let's do our SUVOT problem, start part 2 with this acceleration, right? Okay, let's assume that the rocket's not moving to begin with. I think that's a good guess, right? The final velocity is positive 63.9. The acceleration is positive 12.398. And now we just want to find the time. I'm going to use, I guess V equals U plus AT, right? Okay, so final velocity is 63.9 equals 0 plus 12.398. Oops, there's a 9 in there, right? Okay, times t, right? Well, it's just going to be this divided by that, right? Okay, so 60.9 divided by the answer that I just got, and then I get that the time is equal to 5.1541 seconds. And we have 3 sig figs, so I guess it's 5.15 seconds, right?